Hello, my automation friends. As you know, I have been putting on some videos on this channel, which is mainly to understand the evolution of industrial automation in India. I have not, in fact, put in any videos in the last over a year now. And I'm visiting US now, and I thought it fit that I should talk to some veterans from the automation industry in the US and give you a sort of the evolution of automation in the US and the progress it has made and what the status is today. In the first of the series of these videos, I would be talking to Mr. Lee Pryor, who has retired now, but has been in the forefront and has been one of the veterans connected with the automation industry since the late 60s and early 70s. This interview gives you a lot of insight into how the automation developed in the US and who are the founding fathers of PLCs and other automation equipment. I have broken up this interview with him into 3 parts. This video will be the first part, and I'll follow it up with 2 more videos. I hope you will enjoy it and find it interesting. Thank you very much for accepting to be here, and it's my pleasure. So let me first start by asking you that you have been one of the, I would say, early members of the automation industry.
Yes.
You know, and because I presume automation, like anywhere else, started around the late 60s, early 70s. In India, it was around the early 70s, but probably here it was a few years earlier. And
Right.
You have been, I think, connected with it right from that time, around that time. Therefore, I would want to know, I mean, you did your schooling, your college here, and then, how did you get into this automation business? Because it was very new. I mean, it was some sort of an industry. It just started. Therefore, how did you get into it, and what attracted you towards that?
Okay. Well, to begin with, during my high school days, I started getting interested in electronics and let's just say electricity in general. Learning about electromagnetism, how to make a simple motor, and so forth. And so it was kind of a natural thing to decide when I began my university education to decide to become an electrical engineer. So my school was Marquette University in Milwaukee, Wisconsin. They had a very good engineering school, not a huge university, but a good size, good private university with a really good engineering school. Did some pioneering work, the university, especially in medical biology and so forth in engineering. So I decided to study engineering. Now, unfortunately, I have to admit I was not the greatest engineering student. Like a lot of people, I struggled in my first years, but I stuck with it, and things got better, and I graduated. But significantly for me, that had a huge impact on my life. My university engineering school offered what at that time was called a co-op engineering program. This was a program whereby at the end of my sophomore year, I could apply to work for different companies in our area as an engineering student for not a lot of pay, but I did get paid, and for the experience. So I applied for this program, and I interviewed with at least 2 companies. One of them, which was what was at the time Square D Company, very well known in the U.S. For its electrical products and its controls. And I also happened to apply with Allen Bradley. which was very close to my home in Milwaukee, but I ended up getting an offer from Square D and I accepted it. So in June 1964, I guess you could say I started my career as a engineering co-op student. And the very first day, the first week of my assignment at Square D, the first thing they did was send me to a 5-day class to learn how to use a product called NORPAC. And NORPAC was a solid state transistorized logic system with they consisted of NOR devices from which you could make ands and ors by putting little tiny wires with little tiny pins into little tiny holes and then connecting them. And it was a bit laborious, but the devices were extremely rugged because they were encased in epoxy. So they were almost non-destructible. They never broke, etc. But anyway, the first thing I did was I learned about this very basic product. And that meant that I also learned Boolean algebra and had to quickly understand Boolean. And along with that, I had to quickly understand and be educated on, at that time, what in the US were called ladder diagrams. So in the control world of that day, almost all factories the machines were controlled by relays, industrial heavy grade relays, not little tiny ones, but bigger ones, 300 volt or 600 volt capacity. They were mounted in huge steel cabinets. And basically, I think that one panel of relays probably controlled one machine. And the machines, of course, weren't interconnected unless you happened to run some connecting contact over to the next machine or to a conveyor to tell it when to start or stop, or something very simple. But there was no other means of communication outside the panel. It was just stand alone, control the machine, and then either manually move the part to the next piece or what. But that was my introduction to factory automation. And so I spent that first summer working in the marketing department of that product, answering phone calls, typical for a student. I was a gopher. In other words, I was in a factory with 2,000 people. I was up in the front in marketing, and I was constantly asked to go into the factory to find a part or talk to somebody or do something. So I got quite a bit of exercise going back and forth in this large factory, and I got to know a lot of people, a lot of workers. It was a very good experience. After that, the next thing that happened was my next semester, half a year later, I was assigned to manufacturing engineering. And normally the rotation was you would go to marketing, then a semester in manufacturing engineering, and then a semester in a lab job. Well, I started in the manufacturing engineering, and I don't want to brag, but I did such a good job. The head of the department asked me to stay on. So even though the following summer I went back to school, I actually did all my schooling at night so I could continue to work in manufacturing engineering. And then that fall, they asked me again to just stay in manufacturing engineering. So I did. And of course, that's where I learned very much about the control of machines. We had some fairly good sized stamping presses that I worked on, interconnecting some welding to it. I worked on another machine that failed, and I was asked to analyze and figure out why this machine had failed and caused an accident that injured a worker. And I spent some time analyzing the control scheme and discovered a missing interlock And, so that was my introduction to factory automation. Along with that, as I was near graduation, Square D offered me a job. But by that time, I had determined that rather than being a pure engineer, I was a people person, and I liked sales. And frankly, I had already been part-time working in a sales capacity in a retail store. And I enjoyed the work, talking with people. So I told Square D, well, I could have a job in manufacturing engineering, but I really wanted to be a salesperson. So they offered me the job. Okay. So then, because of my situation, I had to spend, it was the Vietnam era, and I had to spend 3 years after that in the Army before coming back to Square D in 1970. So in 1970, I returned to Square D. I went through all my training for 6 months as a salesperson, which in that case meant visiting all our different product locations and learning about all of our products. But because I started in Milwaukee, Wisconsin, I had an affinity for control products and industrial products. So in Square D of that time, and I still think a little bit today, when you became a salesperson, you either called on contractors and concentrated on electrical gear, transformers, circuit breakers, switch gear, or you migrated over and called on industrial accounts. And I found it much more fascinating to call on industrial accounts. I always enjoyed seeing how things were manufactured, to go into different factories, to observe what they were doing, how they were doing it. And as I got into my sales work with industrial accounts, I found it very rewarding to help them solve their manufacturing problems. So that's how I got into this work in the first place. I didn't have any idea as a young teenager what industrial automation was, and I'm not even sure the term was used until sometime into the middle 70s or late 70s. But so what happened at Square D and a lot of different companies was the evolution of these solid state transistorized logic systems. The next step was the development of what came to be called PLCs, programmable logic controllers. At the Square D company, they got into the business by buying a patent from somebody, taking that patent, and then developing a PLC. And PLCs at that time were very crude. They were huge. I think our main processor weighed about 20 pounds. And, I had to carry it around to demonstrate it to customers. I had to put it in and out of my trunk, take it in, hook it up, all these things. And of course, the I/O were much larger. They were huge. And also the rack was heavy and so forth. So, that's how it started to grow. Now, the history of PLCs, though, really, I think one of your questions was, who was a pioneer? And I think a credit has to be given, at least in the United States. I can't speak for Europe. For a gentleman by the name of Dick Morley, who invented the Modicon PLC. And he did that in response to a specification written by individuals at the General Motors Manufacturing Engineering Center in Detroit. And they were the first people to recognize that there had to be a better answer than relays and transistorized logic. And so they wrote a specification. Dick Morley, probably with a couple other engineers, but Dick was the genius behind it, picked up that specification and for General Motors developed the first programmable logic controller. So the history of factory automation really can be traced to the need of the automotive business to automate their factories for greater efficiency. Because they had such huge amounts of machinery and those production lines for the engine, the transmission, the chassis, all of it consisted of one machine after another. And they were all being at that time controlled by relays, some by transistorized logic like ours. But mostly it was crude, very crude, and no way to communicate between and so forth. So they came up with the specification. After General Motors, of course, Ford and Chrysler at the time quickly jumped in and adopted similar ideas and started buying from Modicon and a few others like Square D. And then everything just kind of took off. Now, in the early days, it's kind of hard to imagine, but the original programmable logic controllers, to program them, there were several different ways. The simplest way to program one was there was a box with buttons, and there were buttons for open contact, closed contact, and coil. And then there were other buttons to connect them. And you literally had a design, you did it like you were designing relay ladder logic, okay? And then you took this diagram in front of you and you began to punch the buttons, okay? And then when you did certain parts of it, then you could transfer it into the memory of the PLC, okay? For a slightly more sophisticated approach, people were using especially the digital PDP-8, and they were pre-programming it with the PDP-8 with paper punch tape, and then that paper punch tape was in turn transferred to the PLC memory. But still, this was extremely laborious. And of course, the machines were slow, but they did the job and got everything started. But to go back to Dick Morley, he certainly, in my opinion, deserves credit. I met the man several times after. So Square D became Schneider Electric. Schneider Electric eventually bought Modicon. I went to North Andover, Massachusetts, where they were headquartered. I had I sat in on some meetings with Dick. He was absolutely brilliant. He was a hell of an individual. He didn't have his own children, but over his lifetime, he and his wife fostered up to 40 children on a farm. So the big treat was to go to the farm, to go into Dick's barn, which was a laboratory, and meet with him in the barn and so forth. It was a real experience. So he was a real visionary. So, and of course, as time goes on, a lot of people jump in and start making PLCs. And I think the next real evolution is that a bunch of the manufacturers and the automotives got together. Oh, and I don't know when the first exhibit was, but let's say maybe 73, 74. And it was in Detroit. So for a number of years, probably the next 10, 12 years, every spring there was a PLC conference, which eventually became an automation conference in Detroit. And all the manufacturers took exhibition space and gathered there. There were seminars, and everybody would meet and everybody would display their products, entertain their customers in the evening, and that's really what led to that helped proliferate. And then, of course, then you started to get man-machine interfaces, very crude ones, but that again made it easier to interface with the PLCs and so forth. So it was a heck of an evolution to watch. And
you're right.
go ahead.
I also know a little bit of history, which I know from India. In India, of course, we started the industrial automation. In those days, it used to be, right, as you rightly said, it used to be known as industrial electronics, not so much
Right.
industrial automation. We started through the drives, that is thyristor drives on the power side, essentially replacing Ward Leonard systems and things like that. And it was more prevalent in the paper industry. The paper industry is where it started, the drives, etc. And then, of course, it
Right.
shifted on to other industries like steel, cement, and etc. It started somewhere in the early 70s. So by about, it was only around the end of 70s that we heard about PLC and PLC started coming into India. Looks like in US it was much ahead. And as you rightly said, Modicon was very well known in those days. We knew Modicon PLCs pretty well.
Yep.
And of course, as you know, my company, we had tied up with Alan Bradley,
Right.
who is considered to be one of the, I think, early movers in the PLC industry.
Right.
Working with, again, automobile companies. I do not know which automobile company exactly. I presume General Motors, but I'm not too sure. I think the PLC market in US grew many fold during that period, and you've been connected with it. Now,